just the simple motors on the tape players in those isolated modules were counter-rotating the entire module.
Mm-hmm.
In the early days, one of the early things that they got spinning this way began to tumble. And they couldn't figure out why it stopped that way, and the reason why is it's an isolated body. It was radiating energy, and the only way it could lose energy without losing angular momentum was to quit rotating this way and begin rotating.
Well, they
that
always
way.
will rotate eventually around their long axis.
Right.
That is a physical thing. So that is why, if you have a tethered spacecraft with a spacecraft here and perhaps the expended propellant tank here, you have a tether in between them. You're not rotating like this.
Right.
You're rotating
along.
like this.
Right.
Okay. That is the stable axis of rotation.
So you're maintaining it around that stable axis.
Yes. Yeah. That's what you have to do. Yes.
Have you talked with the Bigelow Aerospace people about doing perhaps one of their modules, a rotating,
No, I haven't had a chance to have that discussion.
because I think you're going to do a zero gravity, so
Yeah.
it might.
Well, what they're selling is the novelty of being in zero gravity. Although, I've spoken to, Scott Horowitz, who's an astronaut, who's a member of the Mars Society. He says the zero gravity is fun at first and then it gets old. As all sorts of things become very complicated, going to the bathroom, shaving, so forth. I mean, there's a certain, certainly if you're not space sick, which not everybody gets space sick and experiences the nausea, that first day in zero gravity can be fun. And you've all seen these IMAX movies where the astronauts chase little things. But anyway.
Yes. Why not the Mars Society should address the technical issue of rotating spacecraft, because the opponents say it's too complicated, for instance, to set up the rotation properly without parasitic movements? Or how do you obtain the mid-trajectory corrections? Do you have to de-spin and so on?
Well,
I think it would be useful to make our own opinion about that and to have our technical
Well, we
arguments.
we can do that, or even collect papers that have been published by others that are already. I mean, have been many spinning spacecraft that have gone. Pioneer spacecraft that went to Jupiter was a spinner. And they did mid-course corrections and all kinds of things.
Now the crew, however, introduces an element to the fact that the crew is moving and changing,
Yes.
constantly changing the moment of inertia.
Mm-hmm.
Now if they're hibernating on the way there,
No.
not that I'm necessarily, but that's been always a proposal. If they're hibernating and they're pretty well stationary, you don't have a change.
Well, the thing is, if you have a long spin arm, okay, and you spin this like this, and you have this bucket way out here at 1 kilometer, and there's some people walking around in this thing.
It's relatively nothing.
Yeah, exactly. Sir.
So is the study of gravity-related physiological effects a justification for spending some time on the moon before we go to Mars?
I wouldn't think so. No. I think there's a certain argument to be made, as Mike Griffin made today, that going to the moon is a good intermediate milestone to really learn our craft of how to do things in space and to create a team which is really competent before we attempt this greater adventure. Okay, one could debate that. Okay, but once again, and in the process of doing that, you will get some data on 1/6G. Okay, and that's fine. Okay, my issue is not with collecting data that is incidental to a real mission, that including health data. That's perfectly fine. My objection is to conducting a space program whose primary purpose, in fact, is to subject people to unhealthy conditions for the purpose of collecting data, and that's a different thing altogether. And so we go to Mars. I mean, look, there will be questionable health conditions created. Even artificial gravity, there's Coriolis forces. They're confined to a spacecraft. And this and that. There will be the cosmic rays. There will be Well, certainly the actual physical hazards associated with trying to land on Mars, and it could fail and people could get killed. There are accidents that could occur while you're exploring Mars. There could be Martian dust get into the thing. We'll be exposed to Martian gravity for a year and a half, and so forth. There'll be all these elements of risk, okay? But and some of these, what is the health effects of exposure to Martian dust? Okay, it should be studied in as much as we get data on it. But we don't expose people to Martian dust for the purpose of learning about those health effects. We try to minimize their exposure to Martian dust, just as we should try to minimize the exposures of our crews to zero gravity. I'll take yours unless there's someone.
Is NASA kind of using a circular argument in that they want to develop electric propulsion so they can get there faster and minimize exposure to zero gravity? So they can't use, and from that, they can't use the two-body rotation to eliminate zero gravity because you've got to keep the propulsion system running.
Well, actually, no, that's not true. People actually have designed electric propulsion. The electric propulsion spacecraft is so big that you can put the thruster. It's like here's the spacecraft with all its big radiators, okay, and you can have the HAB module here, and the thrusters here at the center of gravity, and this whole thing could be spinning like this. So you can design electric propulsion spacecraft with artificial gravity configurations. I think that as I explained today, I have no objection to people working on electric propulsion technology. I have an objection to people saying you can't go to Mars until you have electric propulsion technology capable of creating quick trips to Mars, because I don't even think electric propulsion technology can create quick trips to Mars. I think it conceivably could be used to reduce the launch mass of Mars missions at slow delivery, cargo delivery, and that's a potential useful application. But in other words, the tall pole that they've identified, we must get there quick. First of all, I contest the fact that that is an imperative, and second of all, if that was an imperative, electric propulsion wouldn't be the answer. You'd be much better off with NTR, which actually is not going to achieve 39-day transits to Mars, but you could, if you really wanted to, you could get a 3-month transit. Although I wouldn't support that because I'd rather send more payload on a 6-month trajectory than less payload on a 3-month trajectory. I think that consumes my time. Thank you very much.